let me kind of, let's see, is that, oh yeah, that's that. Wish there was a hint. Yeah, I can make a turn. Maybe that's the way to do it. Oh, it's not. See? What's going on here? Ah, there we go. So, I talked about bringing a CAD, but I found this okay, so I think it has geometry, but okay, so what I'm going to do is I'm going to put this thing in there, and unfortunately that is a better drawing than the other. So I've got I've got A, B, and C, and then D, and then E. And so I've got all these instant centers and everything, but it turns out I'm going to put A at the center of the coordinate system. So let's go ahead and do a segment from here to there. On my screen, it does not look like the right aspect ratio. And I think this is the same thing. So that doesn't look the same distance. So, but on my regular screen, it does. So up here, I don't know how to fix that unless I just maybe, I don't know how to do that unless I can change the display settings to something that would match not the high def, but more along the 4:3 aspect ratio. So let's see, maybe that. Keep changes. Now let me look. That may not work either, but no, it doesn't work because it still looks. That is that distance. That made it worse. I don't know how to get the aspect ratio correct. But on my regular monitor right here, it looks perfect. On this one, it doesn't look right, and on that one, it doesn't look right. But I think I'm just going to go with it. I think I'll go back to, I don't know anything else to do. I could go try that. Let's revert. Okay, so I'll tell you what I'll do. I'll try this. Keep changes, then I'll work from that for a second. If I work to that, that doesn't work. That's really weird. Okay, so I'm just going to go with it. But if you're on your own system, you can see that better. So there's the link. What I'm going to do is I'm going to make the links red, make them really big, and I'll move over. My next from B to C goes across 5 and looks like down 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So that looks strange. So let me go back and look at that again. Down 3 here and down 3 to this. I guess that's okay. Then C to D goes back 2 and down 5. So here, let me go back 2 and down 5. 1, 2, 3, 4, 5. So it looks kind of odd, but that's okay. Let me make sure I have all my dimensions right. A to B is a 3 and a 3. Okay, then B to C, I move over 5, down 3, and down another 3. That's down 6. Then from C to D, I move down 5 and back 2. Actually, did I move down 5? I moved down 1, 2, 3, 4, 5, and back 2. So I think I'm okay. Then from C to E, because I've got the things labeled. Oops. Let's see, how do you do that? Okay, there's the other thing. I'm going to make my links all red and all thick. Make all my links like that. So now I'm going to draw C to E. To do that, I go across 6, and I didn't designate how far down I went. Go across 6. Let me go back to the other picture. Let's see. Do I have that in the other picture? I do not.
It goes down 3, doesn't it?
Does it?
Because you data at the surface key, you went up to C and then up to E from the same data. Or no, that's 5. 2.
Yeah, 2. You're right. Goes down 2, across to the right 6. Okay, so down 2. Let me zoom in on it so I can get my extra. Down. What did we say? Across.
6.
Okay. 1, 2, 3, 4, 5, 6, and then down 2. All right. And then I'll make that link red. Okay, so there's my thing. It looks, I'm sorry, on the screen it looks kind of shifted. On this screen it looks perfect. On this screen it looks not right. On the projector it looks right. It looks not right up there. So now we were talking about the instant center. I think, let's see, we actually we came up with the two equations. Did we ever solve them? I don't think we did. We never solved those equations. Oh yeah, we did. Here they are. 2.4, it's kind of hard to see, and I can't, every time I zoom in it gets smaller. So anyway, omega BC is minus 2.4324. Omega DC is 8.9189. Now, what I'm going to do is I'm going to try to do this using instant centers. So the beauty here is you can zoom in and out. The other thing that I kind of liked is you can set up a line like that, and then a line like this one, and your instant center is where they crossed. But uh-oh, I didn't want to do that. Okay, so let's see. But let's see if I can zoom in here. I did this yesterday, just in random. I didn't draw this particular one. So if I drew a segment or maybe a point, let's try that. Let's just zoom in and see if that point is at the intersection. I think there's like a glue thing where it wants to do that. Apparently it looks like that point F got put right at the intersection. I keep zooming and you can see the numbers, 1.53333, and the one below it says the same thing. So I think it's good. Now I don't know how to do complete zoom back out, so I'm just going to have to roll the mouse until I get there. Okay, so I'm rolling. Man. Okay, let me use my other finger. That finger's getting tired. Okay. So I discovered, oops, I don't want that here. Delete that, go back to the move. Oh, delete it, okay. Now there is a thing for distance. So if I point that one and that one, now it doesn't look, and unfortunately you can't see this on the screen, can you? There's a little, yeah, you can. That's weird. There's this little button here. Oh, wait. Okay, I got to figure out how I did that yesterday. So let me go back up here to more. Okay, settings. It comes up with something here. This 1 decimal spot to, let's be ridiculous. And so, okay, you can go away now. So it gets that. So it adds more decimal spots. So B to F is 17.4117. And let me go down and do the measurement over here to here. And it just puts it right in the middle. So it can't really control that. So if you look back at the picture, gosh, let me look on my phone, because I can zoom in on my phone. Hang on. The omega of that first link, if I zoom way in on it, it was 10 radians per second. So let me go back and I'll write on this thing. So in other words, this thing, let's see if it works. This thing was 10 radians per second. So therefore, and I'm really sorry about this, but here, let me do it this way. Let me go ahead back away from this and get rid of this. And now if I'm back on the mouse, does it work? Yeah, so it looks like I can do both. So if that's 10 radians per second, let me get down here. There is a vector. Now, okay, I know there's a perpendicular line. Okay, I know there is, I know it doesn't look this way on the screen, but if you look at this monitor that has the correct aspect ratio, this line right here is perpendicular to that line. It almost looks that way here, but it does look, because the aspect ratio tilts it back a little bit. So this is perpendicular to that line. So what I can do, and that's, I just wanted to put the vector there. So here's what I'll do with this thing. I'll take it and I will make it very thin and like dotted so that it's not, so you can barely see it. It's like a construction line on there. But then what I'm going to do, go down here to a vector, and it's smart enough, you notice it kind of jumps to there. So the velocity here should be of point B. Since this thing does this, it's 10 radians per second, and the distance here, actually, we'll just figure out that distance. Oh, except here. Okay, let's see if I can get back to it. Oh. Okay, it's not going to be too surprising what the distance is. Oh, there's my little red spot again. Okay, so if I did from here to here, that is, if you multiply, you have a line that's here. I can use my zoom in. That's 45 degrees. So in fact, that should be 3 times square root of 2. And I'll do it at my calculator so that I don't lose that on the screen. 2 square root times 3, 4.24264. So 4.24264, which is exactly what he's got right there. So that means the velocity that's up here should be omega r, or 10 radians per second times 4.264. So this velocity should be 42.4264. Now, somewhere on this thing, I remember vaguely seeing something where you could, a text. Okay, so I'm going to put this up here somehow. Maybe I can move it. Okay. 42.4264. Now let's just say okay. Okay. Alright, so what I'm going to do, take this and erase all this mess, and I'm going to put that in up here for the, go back to more, grab this thing. I think I should be able to move it. So this should be, I wonder if I could do this. Velocity of A, I'm going to try something. Velocity sub A equal to, and let's see what happens here. Look at that, it subscripted it. Cool. So there's your velocity. Okay, why can I not move it now? Move, okay, select, okay. So there's your velocity. But it turns out that this thing is also, now that you're looking down BC, it's actually rotating around this instant center right here. So as it turns out, if you want to know the rotation, can you draw an arrow circle here? Maybe there's a freehand. Is there a freehand? Do you see a freehand? Construction, measure, segment, circle, transform, more. Let's look at more. Oh, there's a whole bunch more. Oh gosh. Okay. Let's see. I'm looking for just a freehand. There is a locus thing, but I don't know that I want to do that. I want just a freehand. Do you see a freehand? Freehand shape. There we go. This will be interesting. Oh, go away. Okay. So it turned it into a freehand shape. I didn't want to do that. I wanted it to be what I drew. Let's just get rid of it. So in other words, what I'm trying to get at is this. This thing is rotating. This is still 42, but here's your link. So this omega, so velocity of A, which is the 42, is equal to the omega of this thing, which is BC times BC times that distance, 17.44197. So omega BC equals to 42, give me a second, 42.4264 divided by that 17.44197. Okay, give me a second. Okay, that's 10 divided by 17.44197 is equal to 2.43. So that means omega BC is equal to 2.432. Okay, omega BC is equal to 2.4324. And what's interesting is if you look back here, 2.4324. So that's omega BC. Now he shows, or we solved it the other day and it was a minus. The reason it was a minus is because we set up the coordinate system the way we're supposed to, and a right-hand rule tells you this is a plus omega. But in fact, if you look, it's the opposite direction. So in fact, we got the right answer. Now that we got that, we can do this, okay? So I don't know where to store this. Oh, I know what I can do. Okay. Let me go in here with an eraser first and just click, select. I'll select everything I can on the page and then trash it. Okay, so I'm going to go back down to that. There was, is there no freehand shape? Pen. Okay. So in other words, this is our omega, and the omega BC was equal to 2.4, what was it? Yeah, 3, 2, 4. Okay. Now, this will be interesting. Does it go with this? In other words, okay, I'm in the move. Oh, good. Okay, so now, oh, I didn't know you could move those around. Okay. So now that we've got that, we want to find the velocity at C. So the velocity at C, it's as if, at this point, it's as if this is some sort of object that is rotating like that. So the next key is, if that's the case, then you'll go down here and draw a perpendicular like this, and this velocity will be omega BC, which is that 2.4 times this distance times the 19.74. So let's figure that one out. I still have that number on my calculator, so I'm going to multiply that times 19.7456. So I get 48. Okay, that's not too terrible. Okay, hang on. Do the eraser. Okay, it's still on my calculator, so it may go dim, but that'll be okay. So I move back over here. You see, that's 42, and it's 17 away. This is 19 away, so it should be a little faster. So let's do this first. I'm going to put a line that is, I'm sorry, I should have put the perpendicular line. Now that I've done the different things, perpendicular line. There it is, perpendicular line. So all you got to do is select the line you want it to be perpendicular to, and then that. Then what I'm going to do, wrong thing. Okay, what I want to do now is go to move. I want to make that look like more of a construction line. Make it like that so I can actually see it very dimly back there. Then I'll draw a vector. So there's my vector. This will be along here, perpendicular, and its value is going to be, let me go find the text. Select the position. Okay, so velocity of, okay, what was it? C. Okay, let me do it again. Velocity underscore C, which will make it a subscript, was equal to 48.0. I'm just going to, well, I'll go ahead and say, okay, 0298, just because there are other things on there. Okay, so there's the velocity. Look at that. It made the typeset more, that's interesting. I guess I touched it at the right time or something. I don't know. Can you make it, okay, preview, advanced. Okay, that's good. So that's 48. Now the question is what is this rotation? So now I'm moving to this linkage, which is a different linkage than this one, which is a different than this. But what I've used is these common points to work my way through it. Okay, so now I'm going to go down here to that one and say, well, if that velocity is this direction, that rotation is definitely that direction, and that velocity, the 48, is the same as the velocity if C was on this link as if it's on that link, because it's common to both. So it's the same velocity. So it's 48.0298 equals to omega of that link times the R of that link. So now I got to go find that. Now, it's true I can use, what's that? Wait a minute. Pythagorean's thing, but I have these distance calculations, so what I'll do is just use those. So I'm going to find the distance from D to E, and I just saw it. There it is. The distance from D to C. Okay, it's 5.38 and change there. So that means this thing, and let me see if I can find that freehand drawing tool again. Okay, pen. Okay. So now that means this, oops, I got to get rid of that. Let's zoom in on it though too. It won't allow me to zoom while I'm doing that. So I'm going to move it up, zoom in on it, and do a pen. So this thing is rotating like so. The velocity of 48. Wait, I should do this, the calculations off of the other one. Okay, let's see if I can do this. Can you delete that? Okay, so in other words, I should do it here. So 48.0298, the velocity up here, is equal to the omega of this link times the R, 5.38516. So omega of this link, which is DC, is equal to 48.0298 divided by that length, or this length, which is 5.38516. Okay, give me a second. I think that 48 is still in my calculator. Divided by 5.38516. 8.99189. Let's look back, and that's what I got here, 8.9189. And here I got 2.3, but that's good enough. So let's see. Okay, use the eraser and get rid of all this mess. And 8, you know what I'll do? I'll see if I can keep that there and do my pen here. Well, no, wait, let's do it this way. Let's put it in as text. Okay, put it right there. I'm going to try something really interesting. So I'm going to go in here and do this. Omega. What was that? Was that BC? What was that? I don't want to make the thing go away, so I'm going to look at my picture here on the screen. It was omega D CD. Okay. CD is equal to 8.9189. Okay. And notice what it did. That turned into okay, cancel. I wonder if I could make it bigger, but I guess I guess it's good enough the way it is. So you can see it turned the backslash omega into the term omega d CD. So it turns out, according to our coordinate system setup, which is like this being positive, that tells you that that one's positive. If you go back here on this, you'll find that one was positive, the other one was negative. So now, bring up the eraser. The last thing is the velocity at E. Now, E was confined to move up along a line. It was it's hard to see here, but it was a piston that moved along that line, and it was 3, 4, 5. So I'm going to draw a vector because this has to go that way. It has to go up in that direction. So what I'm going to do, I'm going to go back to this little geometry thing, and I'm going to say, I'm going to focus in on E, and then I'm going to kind of try to move it over. I'm going to try to kind of move it over to the left. And what I'm going to do, I'm going to create a line. And this line starts at E, but it has to go over, oh geez, was it 3 and then 4 or 4 and then 3? Okay. It moves over to the right 4 and up 3. Okay, 1, 2, 3, 4. 1, 2, 3. It doesn't look like it on the screen, but that is a that line is 1, 2, 3, 4, and then 1, 2, 3. So that's a 4, 3. So that's the direction that E has to go. It has to go that way, either to the down to the left or to the right. And so what I'm going to do now is take that, and I'm going to do the same thing. I'm going to make it really a light construction line there. You can kind of see it's dotted there. Now, the key is, and I got to move back here, and I know this is weird, but and I should have done these instant center lines a little bit different. Here, let me try this. I'll do the instant center lines green and kind of move them back to here like a funny, then I'll make it green. So these are the instant center lines. So they're kind of special in a way. I'll make them green because they're special. Now the next key is we're on, if you ignore all the stuff, we're on this link. This point goes that way. Perpendicular is this green line. So now I know this velocity actually, and that's a tough thing to figure out that way. But I think it's going to go this way. It's going to be sliding down. So I'm going to put a velocity vector there just as a reference point, and then I got to find a perpendicular, and it'll cross right here, and that'll be the instant center, what looks like this CE. So let me do that real quick. And my velocity vectors are not to scale, so my velocity vector, vector, here's a vector, and I'd like to zoom in here, and it goes down this line here. So that point is supposed to go down that line right there. So I don't think I can edit text, so I'm going to leave the text off and say, okay, at this point, I need to find the perpendicular to that thing. I think it was back up here, perpendicular. So I'll select that line, and I'm going to draw perpendicular. This is going to be one of my this is going to be one of my green lines. It's going to be one of those ones that I'm shooting to, let me make it 4. So it's going to be the one in which Now, here, I'll do it on the screen. Now, it appears like this is some kind of funny, rigid plate that's pinned right here that's rotating like that. If you take this distance times that omega, that would give you that velocity. This distance times that omega will give you this velocity. So you can see they're not to scale. So this being further away, this velocity would be much larger than that one. But that's okay. What this is now, this is a triangular rigid link that's like this. That is drilled and pinned right there and spinning that way. So now, let me go find that point now. Before, the other day I didn't do it this way, but today it seems like I tried this, and I'm just going to put a point right there at the intersection, and there's some extra garbage on the page. So what I'm going to do now is I'm going to go try to find my distances. There's the distance. So I'm going to measure it from C to N, and then I'm going to measure, wait, if I go up here, I'm going to measure, I think I'm still there. I'm going to measure, I did C to N. I wonder what happens if I do N to E. It does. N to E. What if I do E to N? Okay, that's okay. I wonder if they're separate. They are. There you go. Can I just delete that? Yeah. So what is that now? Is that text? Oh, extra small, very small. What is this? What does that do? Pin fix object setting. I've never used this. I started using this yesterday, so you probably have used this before. Bold, let's see. Oh, I like the bold. I'll make them bold. Okay. So now I know the velocity right here. And I know that's the velocity of C. And I know C exists on this rigid link, that one, and this one. But I'm interested in this one right now. So what I'm interested in doing is I'm interested in finding the obvious rotation that is right there. I want to know what that omega is. So how do I find that? Well, V always is equal to omega R. It just depends on which V and which omega and which R. So this is my V. That's my omega. And my R that I'm looking for right now is that one. That's the one from here to here. Okay, so if I'm looking for the omega, omega will be the V, the 48.0298, divided by the R, which is the 4.21448. So let's see. I don't believe that was left in my calculator, but no, it wasn't. Okay, 48.0298 divided by 4.21448, 11.39. Okay, so let me just hold this for a second and put that in as text. Text. Did I pass it? There it is. Okay, I'm going to put my text about right here. I'm going to put a LaTeX. No shoot. LaTeX formula. Okay. Omega. Okay. Which one was that? Shoot, I got to look back at my picture here. On the phone, the omega is of CE. CE equals to, then I got to go back to my calculator and put 11.396. Okay, can I hit it? So there it is. now that I got all that, I can erase all this extra markup that's on top of that. And now I want to know the velocity, finally, of this pin E. In this case, it wasn't necessarily a pin, it was the piston here. So I want to know the velocity of that piston. And it's obviously coming down to the left. So let me go to the top and do a move. Oh no. Oh good. I didn't know you could do that. Okay, I'm very intrigued at that now. Holy, this is cool. Wow, I did not know this could happen. Control Z. All right. Now that opens another thing that we can do. But we're not going to work. We're not going to deal with that right now. Okay. So I lost my train of thought. Okay. So I'm looking for this velocity. Again, this is on this link. Now I know its omega is that. I know its distance is that. So V is equal to omega times R, or this velocity is going to be equal to 11.396 times 7.3913. Okay, hang on. Times 7.3913 gives me 84. So it is considerably further away, so that makes sense. So I did that in the form of a text. So text. Okay, so I'll put the text like right there, and it'll be a LaTeX formula, and I'm going to say velocity of E is equal to, I had it on my machine here, 84.234, and hit OK. And it should put it right there. Get this, get rid of all that. It's all gone. That's it. So you can see the most I did on the calculator was adding and multiplying. I did some division, and the rest was all done right there. So there's the whole system. So what I didn't do on the page, if you look back at the Twitter thing, I didn't finish it, and what I'll do is I'll finish it on Monday. I just got to the point where I found this and this. I did not work my way out this link. So in other words, I did not do this. Velocity of E is equal to velocity of E relative to C plus the velocity of C. So I've got to go take that velocity of C, come back, and find this velocity of E. So I got one more equation to do, and I'll do it on Monday. But you can see now there. So now you can see with these linkages, you got two distinct ways to solve them. One is using the math and the cross products. The other is something like this. That, in fact, I think, I may be wrong, but I think that if you go into the site, that's the book site, they have this thing referenced there. But I've never used it, and I don't know. So can I save this? Save. Oh.
Take a screenshot of it.
Oh, that's a good idea. Oh, what is that? Save. Oh, it saved it somewhere.
It saved it, but you have an account.
Oh, cool. Okay. So now, let's try something wild. Okay, I'm going to try this. Okay, can I open that? Let's go back to this will be interesting. Can I open it? Let's see. I'm going to do the geometry and see if it starts empty and see if I can open. Open. How do I? Oh, file. Ooh. Okay. Downloads. There it is. Wow. Okay. Cool. So now what do I do with that? You know what I'll do? I'll go to Blackboard and I'll shove it on Blackboard as some kind of file. Okay. Maybe another way I could do it. You know what I'll do? I'll email it to myself, and then I'll email it to the whole class. And if they don't know what to do with it, then they're just. So what I'll do? How do I do that? Mail. Or can I push it? Where could I put it so that it would be? Okay, here. Okay. Oh gosh, I gotta log back in. Oh gosh. Don't make me do the. Okay. Okay. So what I'm gonna do? How the heck do I do this? Okay. So I'll just do new mail, and I'll just send it to me for the minute, and I'll figure out what to do next. Geo, and then here we go. Downloads. Open in folder. Do a. Come on, I don't want to talk to you. Let's see. Okay, there I am. And what I'll do is I'll just drop it there. And let's see if I just send it. I want to make sure it shows up first. Okay, why did you not get it to me? Why is it not there? What the heck happened? Sent items. Sent. Well, at least I got it in my own sent folder. That's weird. Okay, I'll have to figure this out, but I'll get it to you somehow. Maybe I could just, I don't know. They're not fighting to get in here at the moment. So maybe I could put it on Blackboard somehow. Where the heck did Blackboard go? Could have swore I had it up a second ago. Okay, so let me just see if I can post it somehow. This is fall, and this is dynamics. And I don't know. Let's just put it in content. Build content. Item? A file. Geo. Browse local files. Ah, there it is. That's it. Submit.
So that'll be on Blackboard now?
Yeah, it's the one called Geo. So
I like how it asked you to make an account and save it, and then it just let you save it anyways.
yeah, I didn't want to, because sometimes there's a verification on the accounts and all that sort of stuff.
Whoever was in charge of coding that just skipped that step.
Yeah.
And they didn't tell anybody.
All right. So let's do a stop.